Okay, for Algebra 2 today our objective is to add and subtract rational expressions. So to add and subtract rational expressions, what that really means is that we're adding and subtracting fractions that have variables in them. And in order to do that, you need a common denominator. Okay. In order to find a common denominator, you find what's in common, and the leftovers. So to find a common denominator, you find what they have in common and the leftovers. So we're going to start out by just finding the common denominator. So all I want you to do is find the common denominator for x plus 6 and x squared minus 36. So to find a common denominator for x plus 6 and x squared minus 36, I have to try to factor. Can I factor x plus 6? No. So I just bring it down. Can I factor x squared minus 36? Yes. It's a difference of squares. So x plus 6, x minus 6. Now I find what they have in common. They both have an x plus 6. So for my common denominator, I bring that down. Bring it over, whatever, wherever you want to put it. Now, I use those, I pull them out because they have what they have in common. Now the x minus 6 is left over, so I attach it. And there's my common denominator. So what they have in common and the leftover stuff. So number 2, 5x plus 10 and 3x plus 6. So we have to try to factor. So to factor 5x plus 10, that's a GCF. GCF of 5 and 10 is 5, so 5 and x plus 2. 3x plus 6 is 3 and x plus 2. So our common denominator is what they have in common. They both have an x plus 2. Now the leftovers are 5 and 3. So I multiply those two. 5 times 3 is 15. And there's our common denominator. Number 3, we're going to do one more of those and then we'll get into some actual problems. X squared plus 5x plus 6 and x squared plus 10x plus 9. So I factor these. So to factor this, two numbers that multiply to 6 and add up to 5 are 3 and 2, x plus 3, x plus 2. X squared plus 10x plus 9, two numbers that multiply to 9 add up to 10, or 9 and 1, so x plus 9, x plus 1. Now, I need to look for things they have in common. Well, when I look from here and here, there's nothing in common. There are no common factors at all. So what that means is I just need all the leftovers, which is everything. So x plus 3, x plus 2, x plus 9, x plus 1. That's our common denominator. It's all of that stuff. All of that is our common denominator. Okay? So we're going to be using that idea to do some problems. So our first adding and subtracting problem, number 1. X minus 1 over x squared plus 3x plus 2 plus x over x plus 1. Okay, so first thing I have to do is find a common denominator. So I'm going to ignore the tops, ignore the numerators, just focus on those denominators. To find the common denominator, I have to factor. X squared plus 3x plus 2 factors into x plus 2, x plus 1. On the bottom, x plus 1, that doesn't factor at all, so I leave it. Now for my common denominator, I look to see what they both have. They both have an x plus 1, and the leftover is x plus 2. So that's my common denominator, x plus 1, x plus 2. And what I do is I write it in one of the spots, in one of the fraction spots. I figure out what it is, I write it once, and then I just copy it into the second spot. So I'm not writing it in both spots, trying to write it in both spots at the same time. I just write it in one spot and then copy it into the other. Okay? Now, look at this bottom fraction. The factor here was x plus 1. Now it's x plus 1 times x plus 2. So what we need to do is figure out what do we have to multiply that top by. Now the way I do it is I cover up x plus 1 and x plus 1. What's left? X plus 2. So I have to multiply that top by x plus 2. Remember when you add and subtract fractions, whatever you do to the top, you have to do to the bottom. That's what we're doing here. This bottom's been multiplied by x plus 2, so we have to multiply the top by x plus 2. To do that, we do x times x, which is x squared, x times 2, 2x. Now up here, if we do that same idea, x plus 2, x plus 1, if I cover up the x plus 2's and I cover up the x plus 1's, there's nothing left. So there is nothing to multiply that top by. So in that case, this x minus 1 just comes straight over. Now I put my numerators together using like terms and putting it in standard form. So that means this x squared goes first because it has the biggest exponent. Then I put my x and my 2x together. X and 2x makes 3x. And then minus 1. And I keep that over x plus 1, x plus 2. So let's try another one, number 2. 3x over 2x minus 2. Oops, I shouldn't have that line there. Plus 3x minus 2 over 3x minus 3. So I factor my denominators. 2x minus 2 factors into 2 and x minus 1. 3x minus 3 factors into 3 and x minus 1. So for my common denominator, they both have x minus 1s, so I pull that over. There's a 2 left over and there's a 3 left over, so I multiply those. 2 times 3 is 6. So my common denominator is 6 and x minus 1. 6 and x minus 1. Now what I do is I cover up my x minus 1s and I look at 2 and 6. What do I do to 2 to get to 6? Multiply by 3. So that's what I do on top. 3x times 3, 9x. On the bottom I cover up the x minus 1s. What do I do to 3 to get to 6? Multiply by 2. Now, to multiply 3x minus 2 times 2, I need to think about this being in parentheses and distributing. 3x times 2, 6x. Negative 2 times 2, negative 4. Then we put our like terms together. 9x plus 6x is 15x. And then minus 4, all over 6 and x minus 1. And there's your answer. Number 3, x plus 1 over x plus 3 plus 2x plus 5 over x squared plus 6x plus 9. So we start out by finding the common denominator. And we start that by factoring. X plus 3 can't be factored. X squared plus 6x plus 9 is factored into x plus 3, x plus 3. So for my common denominator, what do they both have? They both have an x plus 3. So they both have that x plus 3. What's left over? Another x plus 3. So there's my common denominator, x plus 3, x plus 3, So I write that in both spots. Now if I look down here, x plus 3, x plus 3, x plus 3, x plus 3, if I cover those up and I cover those up, there's nothing left for me to multiply by. See, I cover them all up, cover up my matches. X plus 3 matches with x plus 3, x plus 3 matches with x plus 3, there's nothing left. So that 2x plus 5 just comes over. Up here, this x plus 3 matches with this x plus 3. Well, there's an extra one of them. So that extra one gets multiplied by the top. Now, this is where a lot of people have messed up today. When we multiply x plus 1 times x plus 3, you think about this being in parentheses, and you distribute x times x squared. X times 3, 3x. 1 times x is x, and 1 times 3 is 3. Then we put all our like terms together, starting with x squared, because it's the biggest exponent. Then I go to my x's. 3x plus x makes 4x, plus 2x makes 6x. And then 3 plus 5 makes 8 over x plus 3, x plus 3. And there's our answer. Okay. Number 4. Excuse me, sorry. X over x plus 2 minus 8 over x squared minus 4. Now with our subtraction problems, we have to change them. I change the subtraction to plus, change the sign on the top to the opposite, so that 8 becomes a negative 8. Then I do the same things I did on the other problem. That factors into x plus 2, x minus 2. My common denominator. They both have an x plus 2. And then the leftover is that x minus 2. So your common denominator is x plus 2, x minus 2. Okay, so down here on the bottom, x plus 2 matches x plus 2, x minus 2 matches x minus 2, so the top just stays the same. X plus 2 matches x plus 2. There's a leftover x minus 2, so we multiply top by x minus 2. Then I distribute x times x squared. X times negative 2 is negative 2x. Put the top all together. X squared minus 2x minus 8 over x plus 2, x minus 2. Problem number 5. 6x over x minus 3 minus 2x plus 1 over x plus 1. Now when I look at this one, x minus 3 and x plus 1, neither of those can be factored. So neither of those are factored. There's nothing in common. So my common denominator is both of those. X minus 3, x plus 1. So that's my common denominator because there's nothing in common, so I just bring over both of those leftovers. Okay, so x minus 3 matches x minus 3. There's an extra x plus 1, so that's what I multiply on top. So I distribute 6x times x, 6x squared. 6x times 1 is 6x. On the bottom, if I cover up those x plus 1s, there's an extra x minus 3. Now when I multiply 2x plus 1 times x minus 3, and I forgot our first step, I'm sorry, let's backtrack. That's a subtraction problem, so I should have changed that, and changed that first, because you change everything on top to the opposite. So I change that, change everything on top, and now I can go back to where I was. Negative 2x times x is negative 2x squared. Negative 2x times negative 3 is plus 6x.